are going to learn about application in real life through subtopic multiplication of vectors. Firstly, we would like to introduce our group members.
Assalamualaikum and hi everyone, my name is Aisha Teguzu. Today we are going to talk about multiplication of vectors. There's two ways to do a multiplication. First, dot product, and secondly, cross product. But today we are going to talk about dot product. What is dot product? The dot product or scalar product is a multiplication of two vectors that results in a scalar value or just a number. The formula for dot product is A multiplied by B equals to modulus A multiplied by modulus B multiplied by cos theta. To find cos theta, we need to multiply A and B, divide by modulus A multiply modulus B. Theta there is the angle between two vectors. There's a theorem about dot product. If theta is the angle between the vectors A and B, then A multiply B equals to modulus A multiply modulus B multiply cos theta. There's three types of angle. First, A multiply B greater than 0. It is acute angle. The degree is 0, less than theta, less than 90. Secondly, A multiply B less than 0. It is obtuse angle. The degree is 90, less than theta, less than 180. And lastly, A multiplied by B equals to 0. It is right angle and the theta is 90.
Assalamualaikum and hi everyone. For my part, I'll be explaining the application of dot product in real life, especially in mechanics. We will look at what the formula means, where we use it in everyday situations, and then go through real-life examples and solve it step by step. The dot product helps us find how much one vector affects another in the same direction. In mechanics, we often use it to calculate work, which is the energy transferred when a force causes movement. The formula is F dot D equals modulus F times modulus D times cosine theta. F is the force vector, D is the displacement vector. Modulus F and modulus D are the magnitudes of those vectors. And theta is the angle between the force and the direction of motion. This formula gives a scalar, just a number. It tells us how much of the force actually helps move the object. If the angle is 0, the full force is useful. If the angle is 90 degrees, the dot product is 0, meaning no work is done. The dot product is used in many real-life mechanics situations. First, pulling luggage at an angle. Only the forward part of the pulling force moves the bag. The vertical part doesn't help. Second, pushing heavy furniture. We often push at an angle, but only the horizontal component of the force moves the furniture forward. Third, walking uphill. Gravity pulls straight down, but only a portion of that force, the one along the slope, makes it harder to climb. We use the dot product to calculate that part. Fourth, robotics direction control. Dot product is used to check whether a robotic arm is moving in the correct direction. If the dot product is 0, the movement isn't effective. So, in all these cases, the dot product helps us measure the effective component of force that actually contributes to motion.
Next, let's get into calculation. For question 1, the question is a force of 50 Newton acts on a body and displaces it through a distance of 10 meters in a direction making an angle of 60 degrees with the force. What is the work done by the force? In order to solve this, we need to understand how to calculate work done in by applying the dot products in subtopic multiplication of vectors. The formula for work done is W times F times D times cosine theta, where W is the total work done, F is the applied force, and D is the displacement, while theta is the angle between the force and the direction of displacement. Now, let's apply the values given in the question into the formula. Using the work done formula from the question, we can identify that the force are 50 Newton, displacement are 10 meters, and the angle between the force and displacement is 60 degrees. Thus, we can plug the values into the formula. We got that work done is equals to 50 times 10 times cosine 60 degree. We know that cosine 60 degree equals to 0.5. Therefore, work done is equals to 50 times 10 times 0.5. Thus, the total work done is 250 Newton meters or 250 joules. This means that 250 joules is the transferred or used to move the object in the given direction.
Next, question 2. A force is given by a vector F equal to 8I plus J plus 3K and moves a particle from the point M312 to the point N752. Find the work done. This is the answer for question 2. We know that if we want to find a work, we need to multiply force with displacement. We already know force, and now we need to find a displacement. So D equals to M multiplied N equals to N minus M. So 752 minus 321 equals to 431. Now we already got displacement, so we can find work done. To find W, we need to multiply F and D. It will be 813 multiplied 431 equals to 8 multiplied 4 plus 1 multiplied 3 plus 3 multiplied 1. And the answer is 38.
Let's try a real-life example. A student pulls a school bag with a force of 40 newtons at an angle of 60 degrees to the ground. The bag moves forward 6 meters. We will calculate how much work is done using the dot product. We use the formula work equals F times D times cosine theta. Substitute the values 40 times 6 times cosine 60 degrees. Cosine 60 degrees is 0.5, so the calculation becomes 40 times 6 times 0.5 equals 120 joules. That means the student did 120 joules of work to pull the bag forward. Even though the force applied was 40 newtons, only the part in the direction of motion actually caused the movement. This is why the dot product is so useful. It shows how force and motion are connected based on direction.
Question 4. Find the angle between the vectors below. A equals to 3, negative 2, 6. B equals to 5, 0, negative 4. This is the answer for question 4. First of all, we need to multiply A and B. It will be 3 multiplied 5 plus negative 2 multiplied 0 plus 6 multiplied negative 4. The answer is negative 9. Next, we need to find modulus A. It is 3 squared plus negative 2 squared plus 6 squared, and it will be 49. Next, we need to find B. It is 5 squared plus 0 squared plus negative 4 squared. The answer is 41. Now, we can find a theta or the angle between two vectors. The formula is theta equals to cos inverse multiplied by A vector multiply B vector divided by modulus A multiply modulus B. So, it will be cos inverse multiply negative 9 divided by 49 multiply sec 41. The final answer is 101.58 degree.
Last but not least, to conclude, the application of multiplication of vectors is very important in our daily life. This is because multiplication of vectors has the ability to enhance our ability to understand and apply vectors relationship in so many daily aspects like geometry, physics, and engineering. The dot product helps us calculate work, understand projection, and determine the angle between vectors. By mastering this concept, we can analyze forces and motion in various real-world situations better, making it a valuable knowledge in both academic and practical applications.